graph of root f of x when given y equals f of x and exploring the strategies. Okay, we're going to compare the domain and range of the square root of a function versus the function. So the whole idea of is you are starting with some function, linear function, quadratic function, cubic function, and then you are actually taking the square root of that function and identifying key points. Okay, so we're going to start by investigating a linear function of just 1/2 x plus 1, and then we're going to determine the relationship between that and its square root of that function. Okay, so if we were to relate the linear function to a set of coordinate points in a -6, we end up with a -2 on this linear function. -2 ends up to be 0, 0 ends up to be a 1, substitute 6 in, ends up to be a 4, and substitute 16 in, we get a value of 9. So if I were to go now and graph this line, whether you use this set of points or you know, your slope and y-intercept form, which we will in the future, right, with of this line. Okay, so I'm going to draw this as a kind of thin line because this is not my end result, right? This is my function of y equals 1/2 x plus 1. Okay, let's talk about the domain and range of this function. So pretty straightforward. Our domain is just going to be all real numbers. Okay, so now what we want to do is we want to take the square root of this function. So what we're going to do is we're going to start by using a table of values, use those points, get our sketch, and then we're going to talk about some characteristics. Okay, so what does this mean? I want to take the square root of this entire function. So it's like x, it's like a machine. X is my input, so I'm still substituting -6 into the machine. It's doing this work, getting a -2, and right before it spits out our final value, we're going to take the square root of that function. So technically we are taking the square root of our y values. Okay, keynote. We are square rooting the y values of the function. Well, technically, we cannot take the square root of any negative value. So any point when our y values are going to be negative, our square root of that function is going to be undefined or does not exist, right? So if we look here on our graph, this part of our linear line, all of my y values are going to be negative. So this actually, I'm not going to be able to square root this portion of the graph. I'm going to be able to square root this portion of the graph. So essentially anything that's going to be negative originally in your original function isn't going to exist in your new function. Okay, so now if I want to take the square root, well, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So what I end up with is at -2.0, so this point's not changing. At 0 and 1, that point also did not change. But at 6, this point is now at 2, and at 9, it's now, or at 16, it's now 3, which is like way over here. Okay, so technically I just have 3 points to connect here from this graph. And my square root function looks something like this. Okay, so what is the domain of my square root of the function? That is going to relate to always the x-intercept function, which is at -2. So my domain in this case would be x has to be greater than or equal to -2, where x belongs to the real numbers. Okay, Or our other notation form, this would be -2 to infinity. Okay. Okay, so that's our investigation. We now want to jump into, again, domain and range for this function. So just practicing. Again, if this is our linear function, the domain pretty obviously is going to be all real numbers. Okay. For our radical function, or this function would be x has to be anything less than, I'm going to assume this value is at a positive 1/2. Range is greater than 0. Okay, so again, as you can see, if this is my original function and we square root of that function, the new graph is only going to be shown above the x-axis. So all these negative values exist in the new function. Okay? So in summary, so thinking about the relative location of square rooting a function. Okay? So when your original function is less than 0, so when your y values are negative, the graph of the square root is going to be undefined. You're not going to be able to graph it. When f of x is equal to 0, which is technically our x-intercepts, the graphs of the square root function and that function will intersect on the x-axis. So this is like an invariant point. So the x-intercept will always be invariant. That point's not going to change. It's going to be the original function as for the square root of the function. Okay? When the original function is the y values are 0 and 1, the square root of the function will always be greater than or above that function. So as you can see, this would be above this line. And it's only between 0 and 1. When f of x is equal to 1, the graph of intersects the graph of f of x. So again, this is another invariant point. Occurs when y is equal to 1. So when y is equal to 0, the x-intercept, and when y is invariant points. These points will stay the same when you take the square root of the function. And then lastly, when f of x is greater than 1, so all of this portion, the graph of this function will be below the original function. So all of these points end up to be below the other graph. Okay? So, as a note, when taking the square root of function, remember you are square rooting the y values, and all the x values will stay the same. Not doing anything to the x coordinates. If you notice here at 0, I square rooted 3, which is approximately 1 point. Okay? Here, this point here at like 1/2, I square rooted 4, which is now 2, and so on. So we are taking the square root of the y values. To graph the square root of a function, always consider what the base function looks like. First, apply the square root, identify your invariant points, and then approximations to the function last. Okay, so what do I mean by that? Right? So what we are going to start with is we want to think about what this base function looks like without the want to graph just y equals x.